All right, so continuing on with section 4.2 in multiplying matrices, we are going to talk about a square matrix. And a square matrix is kind of just what it sounds like. It's going to have the same amount of rows as it does columns. So a 2 by 2 or a 3 by 3. That's a square matrix. The main diagonal of a square matrix is the diagonal from the upper left corner to the lower right corner. So that would be the main diagonal here, and that would be the main diagonal in that one. And then multiplicative identity matrix is any square matrix named with the letter I that has all of the entries along the main diagonal equal to 1 and all other entries are equal to 0. So for instance, a 2 by 2, the main diagonals are all 1s, but all the other ones are 0. And the same thing would be true for a 3 by 3 or a 4 by 4. So there's your main diagonal. It's all 1s, everything else is 0s. All right, so example 4, it says to evaluate if possible. For a squared, we know that a squared just means a times a. So we are going to have the same matrix twice. And they're 2 by 2s. They're both 2 by 2s. So a 2 by 2 and a 2 by 2. Our numbers match up and our answer is going to be a 2 by 2. So when we multiply the first row and the first column here, we're going to have 7 times 7 and 3 times -2. So that's going to be a 49 and a -6. So our first answer is going to be 43. And then we're going to have the first row and the second column. So we're going to have 7 by 3 and 3 by 0. So that's a 21 and a 0. So that one's going to be a 21. And then we're going to move down a row. And we're going to have that row and then our first column. So we're going to have -2 times 7 and a 0 and a -2. So -14 and 0 would be -14. And then we're going to do the last column. So -2 times 3, so the firsts. And then add the lasts, it would be 0 times 0. So it would be -6 plus 0, so our answer would be -6. So a squared would be equal to that matrix. Then we have b squared. So we have b is a 3 by 3. And if we multiply it by b again, that would be a 3 by 3. So our inside numbers are the same. So we're going to have a 3 by 3 for our answer. And I'm going to pause the video and copy that down so I can scroll down farther. Right, so our first column, our first row and first column. So we're going to have 2 times 2, so that's 4. We're going to have 4 times 5, so that's 20. And then we're going to have 1 times 1, so that's 1. So that would equal 25 if we added it all together. And then we're going to stay with the first row, and we're going to move to the second column. So we're going to have 2 times 4, which is 8. And then we're going to have 4 times 0, so that's 0. And we're going to have 1 times -1, which is -1. So that's going to equal 7. And then we're going to move to the last column in the last matrix. 2 times 1 is 2. 4 times negative 2 is going to be a negative 8. And 1 times 3 would be 3. So that would give us a negative 3. And then we're going to go through and do the same thing again. But we're going to use the middle row in the first column. So 5 times 2 is 10. 0 times 5 is 0. And negative 2 times 1 is negative 2. So if I add that all up, I get 8. And then we're going to stay with that middle row in the first matrix. We're going to go to the middle column. And we have 5 times 4, which is 20. Middles, 0 times 0. And lasts, negative 2 times negative 1 is a positive 2. So that would give me 22. And then last column, the firsts, 5 times 1 is 5. Middles, 0 times negative 2 is 0. And lasts, negative 2 times 3 would be negative 6. So that would give us a negative 1. And then our last row with our first column. Firsts would be 1 times 2 is 2. Middles, negative 1 times 5 is negative 5. And lasts, 3 times 1 is 3. So if we added that up, we would have 0. Then we're going to move to the middle column. Firsts, 1 times 4 is 4. Middles, negative 1 times 0 is 0. And lasts, 3 times negative 1 is negative 3. If we add that up, we get 1. And finally, our last column, our firsts, 1 times 1 is 1. Middles, negative 1 times negative 2 would be a positive 2. And lasts, 3 times 3 is 9. So that would give us 12. And then we have our 3 by 3 matrix for our answer to b squared.